Hello.
Hello. Joe, you are muted.
Hi.
Hi.
I just found out that Zoom needed to sign in. I did not sign in for.
I think 2 minutes more and we can start the meeting. So the next week, Brandon, we are going to cancel the meeting, I think, because if there is US holiday. Okay.
Yeah, I would. I'm hearing that from other meetings right now.
Okay, 5 minutes. So let's start. Let me share my screen maybe, or maybe not, because Joe will share his screen. Anyway, so we have two topics in the agenda today. The first one is telco perspective on the image compatibility problem by Joe. The presentation he also gave on ISC HPC conference. And then we have proposals recording. So the floor is yours, Joe.
Okay, I will start the presentation and share my screen. Can you see my screen now?
Yes.
Yep.
Okay. I would like to introduce the telco perspective about the image compatibility. This is Cao Yuhuan. In short, you can call me Joe. In telco, there is 5.9 uptime requirement. It's quite different from IT or public cloud. For IT public cloud, usually provide 3.9. For 3.9, it means the downtime is around 8 hours per year. But for telecom industry, it demands 5.9. For 5.9, it's quite a high availability and only allow around 5 minutes downtime per year. So the requirement make is the technology consideration quite different in design. And on the other hand, there are other quality of service on the telecom industry. For example, for the latency, deterministic latency requirement, for some gaming or interactive gaming, it requires very strict latency. For example, end-to-end latency around 10 milliseconds to ensure the experience is acceptable. And for the robot remote control, it may require 5 milliseconds end-to-end from your mobile phone to a remote robot, or for example. So it requires that the telecom industry to provide a high performance and low latency processing. Except these two I mentioned, and for the service performance, there are also other metrics. For example, many countries will define the SLA for call job rate. Call job rate, that means if many people make a phone call, only quite few calls could be jobbed. The system must guarantee all calls should succeed. So in many countries, the government will define the quality of service for the telecom. Many countries, for example, here, a lot of countries define less than 2% or even higher requirement on the SLA. So, and the telecom industry is also social infrastructure. The network outage usually will lead to greater impact on the social learning, society learning. For example, for KDDI 60-hour outage, not only people cannot make a phone call, emergency call, it will save life. And even other enterprise activities have been impacted, for example, for parcel service and banking service and so on. And many people impacted from the network outage. More than 30 million. And other, you can find a lot of network outage report, and usually will produce great society loss, economic loss. Except the economic loss, the government will also to investigate and make sure the telecom service will not happen in such case again. And the network, telecom network application is quite different from general IT application. It's a network, not a single application. Network means that a minor bug or minor failure in some part of the system will lead to other parts great failure. For example, in KDDI outage, at first it's just the router misconfiguration, but the router misconfiguration leads to some abandon in messages, and the abandoned messages make the mobile phone retry to connect to the wireless node, LTE node, via LTE node, and because a lot of phone retry is done by machine automatically, so one LTE node will be congested, and one node congested because the system will redistribute the traffic to other nodes for load balance. So other nodes also congested. And because all VLLT nodes congested, and they will suddenly standardly request to the subscriber database. So subscriber database also overload. Because the subscriber database overload, so all people cannot connect to the network. So the phone all are offline now. So in telecom industry, the disaster usually lead by some minor error. It's just like a butterfly effect. The failure will propagate to other parts. So to meet such strict requirement in telecom industry, in the past, the telecom application, which has already been containerized, usually will be tested in-house with their own hardware and software stack. For example, for Kubernetes distribution, operating system, and the server storage network system, and so on, to guarantee the 5 nines availability and to guarantee the latency requirement, and for example, for call job rate and so on. And the system has to be designed in careful and tested in comprehensively, not only for function, for compatibility, performance, resilience, reliability, availability. Dozens of test cases have to be tested. For example, in the flooding flow, we have to make sure the system work normally, even 64 times traffic flow coming. So such kind of test is necessary to ensure the system can work very well in different scenarios. But in telecom industry, it began the cloud native evolution. That means not only to run the telecom application in Windows infrastructure, but also need to run the telecom application in third-party platform. For example, to run the telecom application over third vendors, Kubernetes distribution, and workload operating system, and other vendors hardware. The telecom application cannot understand what kind of software and hardware context will to run. And I just mentioned that usually the IT platform just provide 3.9 availability, but for telecom application has to achieve 5.9. So how to build a system which running over 3.9 infrastructure, but need to provide 5.9 service. How to make sure the telecom service can meet such strict requirement. Therefore, we have to validate to test the compatibility for third parties system, from software to hardware, and the compatibility in whitelist. Only while in-house tested third-party platform and component could be put in the whitelist. And when we deliver the product to the operator, telecom operators, not only the test in Windows side, but also in the operator. Operator has to do some acceptance test and interworking test and compatibility validation. So compatibility is to make sure the telecom application will run in a very clear context. No blending. And it's too late to check the compatibility during the application life cycle. For example, in deployment or scaling or upgrading, because in the life cycle flow, if something wrong, I just mentioned something wrong may lead to the network some failure and propagated to other parts of the system. So uncertainty platform or components may not perform very well, and the unpredictable performance may lead to latency penalty and the SLA violated. So can't avoid the scheduling starter container failure. Any failure may lead to unexpected butterfly effect. So 5.9 availability may not be achieved. There are a lot of double check tests to make sure telecom application can meet strict telco requirements. And because this consideration, usually in telecom industry, the class node should be prepared and validated and labeling before the application life cycle. And telecom application, even if it can run on some platform without compatibility validation, but it doesn't mean it can meet the telecom strict requirements and I can put it into production. Just run is not enough. So in our working group, the problem to solve includes two aspects. I think the first aspect is that the compatibility use cases while runtime is not involved. For example, for HPC scheduling or node validation or cluster lifecycle management, for example, node preparation, introduce new hardware, new software, new operating system, and operating system version upgrade, and so on. And other use cases is more granular image selection, where runtime is involved. For example, to select some compatible image and have optimal performance. And the first scenario, we may use artifact to address such use cases. For the second aspect, maybe we can enhance the image platform object. And between these two aspect solutions, we can share the compatibility keys or the labels. So the idea I mentioned before is that for artifact may provide full compatibility, but for platform enhancement, it's mainly to meet the image selection requirements. And we can reuse the features and introduce some new field, for example, compatibility. And for compatibility, only a subset of the full compatibility, and just use the field which can distinguish image for image selection. we don't need to have all compatibility in the platform object. And in these two in area, we can share the compatibility keys. That's the slide I want to share. Thank you. So if you have any question, please.
So I got a couple questions. First one I'll throw out is, who is responsible for building the images that get deployed in your infrastructure? Are you building them in-house, or are you pulling third-party images that are pulled external?
For image building, it's built by the vendor. It's built by the vendor, not by
So
third party. Yeah.
So there's an upstream vendor that is creating that. And is that the vendor of the hardware, or is that the vendor of an application?
Currently, each vendor has their own full stack system. The full stack system includes the selected hardware and their own operating system distribution and Kubernetes distribution, and the telecom application, the containerized application. For the part delivered to the third party is just the containerized application. So for the different color means they are different vendors. And the telecom vendor mainly just deliver the containerized application, and the telecom operator may build the platform from some IT supplier.
It's not always upstream, Brandon. I mean, you can deliver those images to vendors downstream, basically.
Oh, image will not be published to public registry. It's all delivered offline. Use some package to deliver to the customer.
So if the vendor is providing the full stack of the application, the pointers to the images that you're going to run on that hardware, I'm assuming the hardware itself is also in there. Where is the compatibility coming in?
The compatibility is that for all software and hardware should be tested, which can meet the performance and the reliability. I just mentioned a lot of test cases for the hardware and software and application together. It can meet the requirement.
So to give some additional context as well, I think because if vendor is providing some image, it will provide also artifact for that, for the compatibility, right? So they can test if their application that they provided works well with the specific hardware and so on. And later you take this bundle and provide to customers, and they also run the tests, their admins, just to check if it performs according to requirements. That's why you need this compatibility piece that describe the images, requirements, so on, that they know how to prepare the hardware, how to run all of this stuff, and so on. And you can have also multiple scenarios. You can just take vendor application, run on vendor hardware, and customer is just, requesting some service to be available, right? But it can also be running on the customer hardware as well.
Yes. The telecom application vendor will test some operators demand or vendors' preferred hardware and software to make sure they can work together very well. So
And so what
in-house,
happens if it doesn't match? What happens if the vendor has an image, they define their compatibility artifact that says you must have hardware version A, and the customer pulls that down and tries to run on hardware version B. Should that fail? Should that?
In this case, we will not recommend the telecom operator to run it in production. It doesn't mean the application cannot run on latest software and hardware stack, but just run is not enough because it had not been tested by the vendor fully from different aspects. So it may run normally, but it cannot be put into production because the telecom application vendor don't know whether there will be some issue in performance or latency requirement or SLA and our availability.
And what would stop it from going into production?
Pardon?
I think that would be the thing, like because if you deliver the application to customers or so and they don't pass tests, then you have a bunch of engineers that just carefully checking if this application can run on this cluster and so on. So it's not always about, for example, because you can have multiple scenarios. You can have a scenario where you expect appropriate performance, where you whitelist the hardware, and if that fails, you have a problem because the performance doesn't fulfill the criteria. But there can be also another scenario where you don't have this such a strict environment, but you over the compatibility describe what kind of kernel modules and kernel version can run there because it has been tested, certified, or so whatever. And in the second scenario, maybe you're not so strict about the hardware, but customers run so many applications. The clusters are so big that sysadmins cannot check all the time the documentation and whatever. We have to have some kind of standard 2DFA way of consuming those because it's not like in public clouds or maybe like general use case where people who write their applications will run there and their sysadmins will take care of that and they will know everything. Sometimes it's kind of black box and you have to know the requirements over compatibility metadata to configure and run the applications. That's the whole thing.
Yes.
So would this
Yes.
be some kind of like telecom specific acceptance tool that they would run?
Yeah, customers would provide. There are some tools, generic, if I understand correctly, but a lot of people run their own criteria tests just to see because you have to with those high SLA requirements, you have to test that because you might pay some fee to government if something fails or so. So application vendors provide something with compatibility, and as a site that is running those stuff, you have to make sure that it's running correctly. There is no field for the mistake. That's why it's so strict.
And would that be like, I'm tying together the telecom specific, you're going to run your own tooling versus the OCI side of this, of we're going to attach this data to individual images. I'm wondering if it makes more sense to do that test at a higher level. And so I think the telecom is that higher level, but to capture the requirements, I wonder if it makes sense to capture the requirements at a full application stack level and not an individual image level, because you're going to run multiple images on the same physical node, presumably.
That depends, right? But it would be good to have something that describes you those compatibility on the image side as well as you provide the application. Like the application is provided over the image, so you want to have something associated that will describe you how this gonna work. The application level you're saying that we could describe, I think Kubernetes pod spec is doing that already, because you can have one image and you can run Kubernetes pods differently. So over the pod spec, you define this application level and kind of context. But I believe we need some source of truth which is directly associated to the image, which is in that case this compatibility thing.
Thinking through this, I'm wondering, would you ever have a scenario where you'd have multiple builds of the same application deployed out to different hardware, and you need to use that image selection, or is this strictly based off of a provisioning the infrastructure itself?
In the image, I think we can have some scenarios. I don't think it's gonna be if you have, for example, build for, we don't need multiple builds for x86, for instance. If you have different architectures, then yes, you would have like build for ARM or whatever. This is what I'm talking about. But the same build, the different builds for the same architecture, I don't think it's gonna. Do you think, Joe, we would need that?
Like in this specific picture, you've got the vendor B and vendor D, and each of those have different hardware or something like that, or C and E. Each of those is different hardware. Would you ever say, okay, I'm going to define this one application that can deploy to either one of those, and there are just going to be multiple builds of that application to go to those different kinds of hardware?
It will be same build for different hardware, and whether it's compatible or not. Maintain lot of specific build will be very expensive, because I just mentioned that all tests may include a lot of different aspects and a lot of test cases. You have to test all different images. So it's not economical.
So yeah, that's why in the compatibility idea, there is this thing to put context. If you are running on AMD CPU, then you, for example, require different kernel modules than on an Intel CPU based on what CPU provides you. That's why there is this context that you put into compatibilities. That's why it's a list of compatibilities, not just one big JSON with key value parse. I would say the image selection requirement is mostly coming from HPC side.
I think we're seeing it at other levels too. We're seeing it from people are building multi-platform images today that are looking at, there is AMD 64 version 1 is what most people build their stuff against. There are multiple versions of AMD 64 though, and those versions are kind of just stacked on top of a rough collection of different syscalls you can run against those CPUs. And so knowing which of those calls are available to compile applications with newer functionality is something we're seeing from end users.
My perspective on the whole problem is 4 years, like I would say more standard use cases have been covered, like where you run containers where you don't need specific OS requirements or hardware requirements. But once telco, because telco is always delayed a bit because of this high requirements, they started moving from virtual machines to containers, then we are facing the problem right now. And there is more, because it's not only about the Huawei that is requiring that. There is more telecommunication components that require this. And Silva project in Europe has also been established to run container network functions. To run container network functions instead of virtual machines, you just have containers. So that's the thing.
I think we're also seeing it from the cloud space, where clouds are offering that we can run this on a new CPU that's more power efficient and whatnot, has all these functionality. That was a big push for everybody going to ARM previously. And so you'd have multi-platform with the AMD and the ARM implementation. Then someone in the cloud could say, hey, I can save a bunch of money by deploying on this hard ARM infrastructure. If they can save a bunch of money by recompiling the same application or a newer version of the CPU that has more efficient calls, they can get more throughput through that same application. They can serve more customers with that same application just running on a newer CPU. They would want to pick the newer build of that application to be able to leverage that CPU. But they still want to be able to fall back to the old one if they ever deploy this on some old laptop that a developer has in the closet.
I see. Makes sense.
Yeah.
So anybody has more questions to the presentation?
I'm not against still chatting about this and saving the recordings for a future meeting if you want to keep going over this. I don't want to rush this since I don't think we get Joe to present very often. Yeah, my big question is I want to make sure that what we're doing here satisfies your use case, your requirements, and that either we're satisfying it, or if we're not satisfying it, it makes more sense to do it in a different place. If it makes sense to do it where we're trying to implement this stuff and we don't implement the solution for you, then I think that's a problem. We need to fix that. So that's where I want to make sure we're addressing your concerns.
Yeah, thanks for that. We are hoping that we can come up with some good solutions that will be happy. I mean, not only telco, but other use cases as well, right? Organizations. But
yeah,
because I saw HPC was complaining about this compatibility thing when I was looking for container D image selection. They complained about that a while ago, but I'm not sure if they came up to talk about this to you or not, but looks like they didn't. So that's once we created the proposal, they got interested in that as well, confidential computing, the kata containers. But I don't see any input from Zvonko for a while already from NVIDIA. But I talked to him at KubeCon and he said he's still interested in that, but looks like he's busy with some different things.
The phrase that I've heard in the past is that OCI is it's like endurance-driven development or something like that. Whoever sticks around the longest is the one that finally gets the spec to be written in the way they want it. And so people drop off as they get busy with other stuff, and then the spec just kind of goes a different direction. So
I see. So it's about being stubborn.
yes, that's the only reason we first got into the spec, is that some of us were very stubborn.
How long it took you to include reference? 2 years, that was?
Something like 2 years, and there were multiple suppressions of mutinies in the process. So it was not the most fun process. And from what I've heard, that is very minimal compared to the original OCI 1.0 stuff when it was coming from people pulling different directions from where it came from in Docker, and then other groups that had their own interest.
See.
yes.
So we've got 20 minutes. I can probably go through mine in 10, but I'm worried that we're gonna like rush you on the other side.
I think I need 10 minutes as well to talk about compatibility artifact. It's not gonna be long. I don't want to make it complex for maintainers. We can get into details later.
Okay. In that case, I'll go ahead and let's see if I can do this. I'm setting up a new laptop, so as soon as I click any button these days, it's got a new window of something different happening. Let's see if I've got this right. Window capture, desktop capture. Let's see. I think I'm sharing proposal A.
Yes.
All righty. And so on this one, super simple run through here. I'm leveraging the fact that if we have multiple manifest in there, the first matching entry should be used that a runtime knows about. And this probably needs to be a slightly reworded at some point to be like the best match that the runtime is aware of that it can differentiate from any other match. And so if the idea here is that if a runtime can't differentiate between two matches, that it picks the first one. And what that gives us is the ability to put extra data in there, whether it's a new field, or in this case, I'm leveraging annotations. We can put some extra data in there. And as long as we put it in future matches, those won't override the default if a runtime is not aware. And so that's how we get the backward compatibility with old runtimes that aren't aware of what we're doing. With this, for proposal A, what I was leveraging was that if you add an annotation, this is completely defined by the vendor. Maybe we can do stuff on OCI. I'm not being very picky here, but an annotation gets defined by the image producer. And then the consumer of that on the runtime would be able to configure their runtimes to say, I care about specific annotations and I'm going to rank those higher than other images that I see. And so it might say, I've got this specific GPU installed on my machine. Anytime I see an image that says it has been optimized for that one GPU, I'm going to prefer it over any others, or pick and choose whatever hardware environment we've got, something along those lines. And the individual runtimes could put priority on those and have like a ranking or a scoring of some kind on those different annotations, and sum up multiple of those entries if they see multiple matches, multiple annotations in a single entry, to be able to sum up those rankings, to be able to say, okay, one that's got 3 annotations that matches might have whatever score it gets that ranks higher than something that only had 1 match. And so then the rest is just going through our boilerplate. But the key here was that it was very much up to implementations that are building these images to be able to define their own annotations, and up to runtimes to be able to configure the runtime. And so this would be like a configuration file or command line flag or something like that at the runtime level, containerd, cryo, pick any of the other podman, something like that that's running the images, to be able to inject a config file that says, on this individual install of this runtime, I prefer these annotations. So that could be some kind of runtime deployment. So that was proposal A. Proposal B shifted a little bit, or sorry, E shifted a little bit, where instead of saying I was going to ignore any unknown annotation like we always do, I wanted to put a hard requirement here that said we actually must match everything in here. And so I was going to use the reserved field that we had from before and finally define it. And so I pulled in the text that we had from back in the day, where for a specific platform entry, the features would be filled out. And if that features was filled out, the runtime must support each of those features. And if it doesn't, then it can't pick that image. It's like seeing a platform that you don't recognize. You would just refuse it as an unknown platform. And by specifying these features right now, it is keyed off of the CPU features. That was the original intent of that. Potentially, you might be able to find some other ways to put other features in there that runtimes can be aware of that aren't specific to like CPU instructions. But the key here is that this would be reusing a reserved field, so pulling out a reserved and actually putting it into the spec. But anytime a runtime sees it and doesn't recognize anything in here, it's an automatic reject. It's not like it's going to ignore an unknown field. It's going to be, everything in here should be known. It must follow each one of these. And so it was 2 very opposite approaches to this problem. This is very limited in scope to just CPU features that it recognizes. And then anything outside of that, it gets completely, if it doesn't recognize it, it gets rejected by that runtime. And so, yeah, I promised I would take 10 minutes. I only took 5 there. So that's more time for you, Marcin.
Okay, cool. I will share my screen then. I hope you can see that.
Can.
So instead of showing a specific proposals regarding artifact, we came up with this document that will summarize basically the whole idea. And not to make it more complex, we wanted to make it simple for you. So that's why we took the common part, and I'm gonna to talk about this right now. So basically, we want to introduce a new standalone artifact for compatibility. We want to introduce artifact type OCI image compatibility. And for compatibility specification, we want to create a new media type image compatibility spec. We want to associate artifacts with images over subject, and we want to discover those artifacts over reference API. If one image has multiple artifacts, we would say that it's up to client to choose the correct one. However, as a default behavior, it would be recommended to get the most recent over created timestamp. So let's talk about compatibility specification. The schema is very simple. We want to have a list of compatibilities objects. Each compatibility object would have fields like compatibility labels. This would describe the requirements of operating system or the requirements of image regarding operating system or hardware. The list of OCI labels is yet to be determined. So we only here discuss about the artifact design itself. And then we have tags fields that would help you to identify and put some context into compatibility object, because you might have different requirements based on, for example, CPU vendor. So we have here tags Intel with different CPU features that is dictated by Intel CPU, and the same for AMD. So it's a very simple idea to put everything, the full compatibility metadata, into artifact and just associate them with the image manifest. And we have some point about artifact justification why we want this, because we don't have a limit by the size as index might have. Also, we don't want to clutter the index with a lot of extra metadata that may have contain even duplicated entries, because different manifests can repeat labels, then your index will rapidly grow, which may also impact frequently querying clients. And standalone specification is more flexible than just a new compatibility field in the index, because it could be released as well as an experimental version, and we could operate on that, and we can attach it to already released images without a problem. I would like to mention as well that this artifact wouldn't work well. I mean, wouldn't work together with container runtimes. This is not the goal. The artifact is mostly for maybe HPC scheduling, for cluster provisioning, and other use cases that don't want to involve container runtimes at all. Yeah, basically that's all. I will send the link to the documentation to this document somewhere as well.
Cool. Well, we each said we needed 10 minutes. We each took 5 minutes. I say we're overachieving here.
Cool.
But yeah, I think the key thing on each of those proposals was that A&E are very much focused on image selection, and the artifact is very focused on cluster provisioning, something along those lines, node provisioning.
Yes.
At a higher level.
Exactly. Okay, I guess we don't have much more topics, unless anybody wants to talk about something specific.
Nope, I'd say the administrative, next week we're off, so cancel that one. I will jump up onto the Zoom recordings and pull this one and get it pushed over to YouTube sooner rather than later, and drop that link over in the OCI Slack so that other people can follow along, and I'll drop the timestamp so they don't have to watch the whole meeting to get 10 minutes of recordings.
Cool. I will also join the weekly meeting. Maybe there will be some feedback, or I can pressure other maintainers. Okay, thank you very much.
Sounds good. Have a good one.
Thank you. Thank you.
Thank you.
Bye.
Bye-bye.
Thank you.